Ideal gas law comes from a number of different observations made by scientists over the course of about 200 years. The first relationship we'll talk about is known as Boyle's law. And Boyle's law states that if you keep the temperature of a gas constant, as well as the number of particles constant, then the volume and pressure are inversely proportional. That is to say, pressure times volume will equal a constant. Now, this is only true when temperature is constant and we're not letting in or letting out any gas molecules. The second relationship is known as Charles' law. Charles' law said something similar, except that he kept the pressure constant inside of a gas chamber, and he also kept the number of particles constant, but what he found was the volume would increase along with temperature. That is, volume is proportional to temperature when we work with gases. Well, Boyle and Charles got together and they came up with the combined gas law. That is, the pressure and volume over the temperature at one set of conditions is equal to the pressure, the volume, and temperature at a second set of conditions. Now, it's important to note that temperature must be Kelvin when using this, because if we try to use Celsius, if you put Celsius into one of these equations, then you'll have 0 in the denominator, and we've broken science. And we don't like to break science. So remember, we always have to use our temperature in Kelvin here. Now, after the combined gas law, there was another law by our old friend Avogadro, who said that the volume a gas occupies is equal to a constant times the number of moles of gas that are present. Yes, our old friend moles is making a reappearance. And over here we can see an application of Avogadro's law by a cat lung being inflated by having air introduced into it. You can see the amount of volume increases substantially with just a little bit of gas. Well, factoring in Avogadro's law, we arrive at the ideal gas law. That is, pressure times volume equals the number of moles of gas times the gas constant R times the temperature T in Kelvin. The gas constant R is 0.0821 liter atmospheres over moles Kelvin. So when we work with ideal gases, we have to talk about volumes in liters, pressures in atmospheres, temperature in Kelvin, and number of particles in moles. Notice the ideal gas law does not take into account the size of any of the gas molecules, nor any of the intermolecular forces they might experience. Finally, when we work with gases, we often have mixtures. And when we talk about mixtures of gases, we have our total pressure, but we also have individual or partial pressures of each independent gas. That is to say, Dalton's law says that the total pressure you experience is equal to the pressure of each gas's pressure contribution to the overall whole. That is, P total equals P1 plus P2 plus P3. This is essentially chapter 11 boiled down into the simplest form I could get. If you'd like to see problems involving these equations, please refer over to the worked problems section of this module.